Okay, here we have quite a long multi-parted question about circles. On this kind of question, there probably will be lots of re-entry points, so keep plugging away at it and don't give up if you find any particular part difficult. First thing we've got to do is go from the equation of the circle to the coordinates of the centre and the radius. And on this occasion they don't actually lead us by the hand through the method for doing that. What you need to do is set up your standard form of your equation in terms of two normally squared brackets. But look, we've got x appearing twice, but y only appears once. So it's going to be a squared bracket with x, it's going to be a y squared term, and then it's going to be something on this side which will be the radius squared. In order to do the squared bracket, I suggest you just take the x squared and the minus 4x, you go on one side, and you complete the square on that. Okay, once you know what that is, you can substitute it back in with the y squared and the minus 14 and rearrange till you've got it in this form, and then if you know your standard equation of the circle, you should be able to just read off the coordinates of the centre and the radius of the circle, and they give you a clue. We know the radius of the circle is going to simplify in surds to something times root 2. Then in part B, we've now got a chord of the circle with length 8. You're going to need a diagram here. It won't need to be very accurate, not a lot of detail on it, but you need a circle with a chord. You need to write the length of the chord on it, and we need to do the perpendicular distance from the centre of the circle to this chord. So you draw a line from the centre to the chord at right angles to the chord, and you'll find that you can draw another line, a radius joining an end of the chord to the centre of the circle, and if you do that you will have a triangle that will be very useful to you, in which you know two of the lengths. And because it should be able to convince yourself that it's a right angle triangle, you should be able to find the missing distance. But this is all about having a decent diagram. You may have an example of something like that in your notes that will help. And then part C, we've got a line, and we are looking for point of intersection of that line with the given circle. So points of intersection is code for simultaneous equations. Here's one of our equations. What you're going to do is substitute that into an equation of the circle. You've got two versions of the equation of the circle. The original one there is probably the safer one to use. So if you put this in a bracket and you substitute that in that equation and hack through, being careful with your k's, you should be able to end up with this. It's a show that question, so this of course is your end point, not your start point. c.e2, they write it all out again to emphasize this is the start point for c.e2, and we now want that to have equal roots. Equal roots is a code phrase. This brings your mind back to work you've done right all the way back to chapter 1. Equal roots or distinct roots or no real roots all are indicating you're using the discriminant. If you've forgotten it, look up the formula for the discriminant and set out your stall by saying what you want the discriminant to be in relation to 0. Do you want it to equal 0 or be greater than or less than 0? Having done that, you've got to decide what A, B and C are. Okay, they've helpfully written the terms so that you should be able to see A and B and C. Set up your discriminant, solve an equation for K. It says values of K, so maybe there's going to be more than one. And then finally, we've got to describe the geometrical relationship between the line and the circle when K takes either of the values found here. So K, in C part 2, it had equal roots. A particular thing happens when you're trying to find points of intersection and you get down to a quadratic equation with equal roots. You might want to think about the three possible things that could happen when you take a line and a circle and try and find points in common, and it's just one word we're looking for that describes the geometrical relationship of one of these three cases that corresponds to equal roots. Good luck.